So we're going to have a look at this example. A can of dog food contains 500 centimeters of food. The manufacturer wants to receive maximum profits from making sure the surface area can be optimal. Let the radius be R and H be the height. Find the dimensions of this to give the minimum surface area. So let's start off with a bit of a sketch. A can of dog food is going to look like this. What does it say the radius is?
R.
What does it say the height is?
H.
H. So how do we calculate surface area? Does anyone know the formula?
Surface area would be
Mila?
2 pi r squared plus pi r squared 3 times height. Sorry.
Okay, so just reminding us, where does this part, where does this formula come from? The circle? Where does this formula come from?
Area of the curved part of the circle.
The curve.
This is the perimeter of the circle. And if you multiply it by the height, then it brings it down and gives us the curved surface area.
It's on the formula sheet.
It's on the formula sheet.
Lovely. Absolutely.
Okay, so can we differentiate this at this point?
No.
Why not?
We have two variables.
We've got two variables. So how do we get rid of one of the variables?
Well, we know that the volume is equal to pi r squared times height. And the volume is 500.
Right.
So
Excellent. Typically, with this type of problem, we want to maximize this, so we have to differentiate the surface area formula. Typical question, this one. You can't differentiate this at the moment because we have two variables. We want to get rid of one variable. So usually there's a clue in the question that lets you create a second formula. And what Christian mentions is that V is equal to 500. But V is also a formula that we can calculate using
pi r squared times height.
pi r squared times height. So what we do is we can eliminate the height from the surface area formula using the volume formula. If we can rearrange this.
Height is equal to 500 over pi r squared.
Height is equal to 500 over pi r squared. So this means that S of R can be simplified to 2 pi r squared plus 2 pi r, and then we replace H with this expression. 500 over pi r squared. Now, can we simplify that?
Yeah.
Where can we simplify?
So the pi is visible.
Sophie? The 2 pi r is going to cancel with that pi and that one of those r's.
So you 2 times 50 over r.
And we can do 2 times 500.
Sorry, I think 550.
Yeah. So this will give us 2 pi r squared plus, what's 2 times 500?
1,000.
1,000 over how much?
R.
Over r. Look how much simpler it is now. Now have a go at differentiating this now for yourselves in your notebooks.
4.
It's square. It's R.
We derive it, right?
You won't call it 500.
Oh, okay.
Say what this is.
Yeah, it's like
Label.
1,000 or power 2.
Why do I say the SDR?
because S is the surface here, and then R is what we're like in the
Differentiate with respect.
Yeah.
1,000 or to power.
Did you get it right, guys?
I don't think so because you just converted this.
you convert it, now you have to, yeah, like the conversion, could it be
enough?
1,000?
Yeah, that's correct.
Or how many?
This equal sign is wrong.
Yes.
Do you basically?
So then now we divide it, next line times 1,000?
Yeah, okay, so there is no
There's
formula there. Yeah, change the sign.
Oh,
It's
so
square.
It's easier than turning something
Okay,
negative.
so if it's a square at the bottom, then you're changing the sign, multiplying the top by 2, and making
Yeah,
actually quite like. So you need the formula like this is again, but you can just memorize that. That's usually the answer.
Yeah.
All right. So what do we have here as our answer?
4 pi r minus
Minus
1,000
1,000 r
r squared.
So clean, so beautiful. I would adopt that. I would give it a home.
Okay. So we want to find the optimal values of R that will give our minimum and maximum surface area. How do we do it?
You equate the area to 0.
Okay, so we set ds dr equal to 0 to find the extreme values.
Maximum,
Or it's actually minimum going to be. So this gives us 0 is equal to 4 pi r minus 1,000 over r squared.
So you take
So have a go now at solving that. You can solve it any way you want. You can rearrange it so that it works quite easily, or you can end solve it. Make sure you look for multiple solutions in case there are, because we've got some squared values in there. You can graph it.
Oh, yes.
You can end solve it. You can just rearrange it.
And so maybe 4.30.
Sounds good. Try and end solve to see if there's any more after 4.3.
Okay. This is graphing, so that's just so
You don't need to consider negative solutions because
Yeah,
yeah.
negative radius makes no sense.
There's two solutions. Which one's the other positive? Just lose r squared. And graph.
I just got the same email.
Yeah, but she didn't do my ED. What does parchment mean?
Parchment? Is it
From my
for
previous or my transcripts?
I think so. Yeah.
Okay, let's have a go at solving. I'm just going to try and end solve. 4.3 did you say? Let me see how it works. 4 pi
Here I got
r
8.92.
minus. Check you're working.
I didn't mind it. No, I didn't.
I'll do that in a minute.
Pi r equals to 1,000 over r squared, and then I
Uh,
plus.
Let me do that in a minute. So here on this one, we want to solve for r. We don't want any negative solutions, so we'll look in this interval from 0 to 100, because negative solutions for r don't make sense. We get 4.30. So this implies that r equals 4.30. I'm just going to check that there isn't another solution. So I'll raise my lower bound to 4.4.
But there is. Oh wait, what?
And then there's no solution found. So that means if we only have one solution, we don't have to check whether it's a minimum or a maximum. It can only be the minimum.
Sir, could you check through 0 to 4.2 maybe? Because that could also be possible.
No, because I went from 0 to 100 and it finds the closest up from the lower bound.
From the lower bound.
Yeah, so from 0,
Okay.
when it hits 4.3, that means there's nothing below that.
Okay, got it.
There could be negative solutions, but they would make no sense in the
Yeah,
context
it's in the
of
context of
in the context of the question. So at this point, I'm going to go back and read the question again. At this point, it's important to go back and read the question and make sure you've done everything. So we've got r is 4.30. It says, find the dimensions. So it's usually the last sentence in the question you're checking as well. So find the dimensions of the can that will have the minimum surface area. We don't need to find the surface area. Sometimes it's asking for what is the actual volume of the surface area. Read the question again at the end of these ones, always, and check what it is you're after. We're not quite done. Why not?
Because we've only found the.
It's dimensions.
No.
What have we not found?
We've not found the height.
The height.
The height. We've got a formula for height that we made earlier.
We plug in the value into
Let's do that now on the calculator. We've got the 500 over pi r squared. So
500 over 4.3.
500 over pi times, and then do control answer to pull up your previous answer, square it. Ooh. Oh, all right, I gotta go get my answer. I get 8.60. Yeah. So h equals 8.60 units.
Centimeters.
Centimeters.
I
Okay.
got 8.61. Oh, but I didn't put in a 40. Okay. Because I graphed it. Oh, okay. So maybe I should have done it using. Oh.